Lesson 2, Defects in Software. By the end of this lesson, you're going to understand defects in software, defect classification, sample template for defect reporting, defect tracking, defect lifecycle, defect resolution, and finally the defect retesting. Let's dig in. Defects in software. Introduction. A defect is a failure in the software system. This slide is going to list the various components of the complete defect below. First is the defect ID. Then we have the defect description, the severity and priority of the defect logged, the detected by and detected on date and time, the environment in which the defect was found, steps to reproduce the defect, a software version, test data used, a concerned test case if applicable, and detailed expected results. Defects. Classification. Let's classify the defects into various categories, as shown in the slide. Number 1. The showstopper. It stops further test execution work. Number 2. Critical. Chances of application crash and data loss, so the development team needs to be informed. Number 3. High. There's a major loss of functionality here. Number 4. Medium. There's a minor loss of functionality. Number 5. Cosmetic. The issue is of low importance as it does not affect further processing and testing. Let's take a look at the templates. The standard template of the defect report contains the following elements: the reporter, the product, the version, the platform, the operating system, the priority, and of course the severity. Click on each of the items to learn more about them. The reporter. It shows the name and email of the bug reporter. The version. You guessed it, this shows the product version. The operating system. This will show details about the operating system like Windows, Linux, Unix, etc. It would also mention the version of the operating system like Windows NT, Windows 2000, and Windows XP, if of course the defect was found on Windows. Severity. For any defect, severity is assigned based on its impact on the software's functionality. A critical defect is preventing the further functioning as well as testing of the application, so it needs to be reported immediately to the programming team. For example, when the customer is trying to open Raise New Purchase Order, or PO page, and the screen is showing internal server error. A high-priority defect is affecting specific functionality of the application, but other features of the application are working properly. In this example, it would be when the customer is trying to edit the existing PO, but the screen is not allowing more than 5 items to be added in the single PO. Then there's medium-level defects. Medium-level defects are those which affect a selected process, but it has a workaround. Here, chances of data loss are much less. To illustrate this, when the customer is trying to edit in his own middle name, the screen is not allowing this action. Finally, the defects which are cosmetic level are known as low-level defects. An example of this would be the spelling of the communication address is wrong on the Edit PO screen. The product. That shows the details of the product on which the testing was done. The platform. This shows the hardware platform on which testing has been conducted and the defect was found. The priority. The priority means how early the defect needs to be fixed so that the impact due on the defect of the overall software system can be minimized. For example, showstoppers need to be fixed immediately, so the priority is the highest. Priority is generally categorized from P1 to P5, where P1 means fix the defect with the highest priority, now, and P5 means fix the defect when time permits, but before the delivery of the final release. Defect tracking is the process to monitor the progress of the defect from its detection until it's closed. The relevant information is entered and updated from time to time into the defect tracking tool. The advantages of defect tracking are: number one, the overall software system development and testing become faster and more efficient. Number two, each and every defect can be tracked until it gets fixed. Number three, improved software quality for the delivery to the customer. And number four, the effective calculation of the overall efficiency of the testing team. Let's take a closer look. The typical diagram of defect life cycle starts as a flowchart, starting as new when the defect was added. It ends as closed if the defect is fixed and rejected if the defect was entered due to a misunderstanding. Click each stage to learn more about them. Reopened. The defect is not yet fixed. New. When the defect is reported initially, by default the status is going to be new. Open. The quality assurance personnel or project manager reviews the defect, determines the priority, then changes the status to open and assigns the defect to a member of the development team. Assign. The manager assigns it to a developer for fixing. Test. It can be treated ready to test after fixed by the developer. Verified. The defect is verified by the tester. Closed. After verification by the tester, the project manager assigns it to the status of closed. Rejected. The bug is not valid as per the requirements or design. Deferred. This will be delayed and handled later as an enhancement. Defect resolution. The purpose of defect resolution is to verify that all of the defects are reviewed and resolved with full efficiency. The most effective method of defect resolution is to conduct a project stakeholders meeting. Generally, the meeting is conducted for the discussion of defects found in software testing. The stakeholders who need to attend this meeting are the development team leader or the manager, the testing team manager, then the test analyst and business analyst to represent the business side. Sometimes the presence of the database administrator is essential, as the database level issues can be resolved then and there with his or her help. Defect retesting. Let's take a look at the process of defect retesting. First, the identification of the defects with the status of test, which are pending testing for a longer duration. Next, the test analyst retests all such defects and updates the status to either reopen or verified, as per the initial post-testing status. As we move on, the test manager would need to provide daily status updates to all the stakeholders on unresolved defects. Then we would closely watch the deferred or reopened defects, if it's needed. And finally, the deferred and reopened defects need to be fixed before the final release. Student engagement activity. As part of the student engagement activity, identify information about the inadequacies in the following defects